Hey guys, my name is Ethan, this is Carberra. Welcome back to the series where I teach you how to code in Python. Today we're talking about error handling. So we've talked fairly in depth about error tracebacks and that. If you haven't heard about that or you don't know what error tracebacks are or anything like that, then go to episode 6. I'll have a card up in the top right corner of the screen. If I forget, someone do remind me. But today we're going to be learning how to actually handle flows and how to do other things on top of them. So the first thing we're going to do is we're going to the simplest way to do it is to just try, and we actually need to save this as a Python file. That would help. So no, try except.py. The try x equals 1 divided by 0. That will throw a 0 division error. So what we can do is we can do except, and then we can do just print there was an error. And if we run that, we'll see that there was an error. However, that's not amazingly useful right now. So what we can do is we can do except exception as E. And then we can just print E in here. I think I'm not actually sure how that will return out, but there we can do. There we go. Yeah, so it returns the actual message itself. So we're doing. So we're checking to see if the exception is of type exception. It's not quite the base exception. I think you do have a base exception there as well. Yeah, but exception inherits from that, and then all other exceptions inherit from this. So this is what you would expect to see if there was an exception, and then we can do as E. This just sets the exception object to be an E, or the variable E, and then because we're calling the string method of E to put in a format string, then we just get the message here. I think if I do just say print E, I think it will actually just print the. Oh no, it is just printing the message straight up. Okay, that's fair enough. So that's another way you can do it. However, you may get into the situation where you want to handle for a very specific error. So you can actually specify specific errors as well. So in this case, a 0 division error. And this will only call this bit of code if there is a 0 division error. So we can say, oh, there was actually a problem there. Something else crashed. Oh, E isn't defined. I forgot. Actually, can you do... I'm pretty sure you can just keep that. Yeah, you can. Okay. So instead of getting just a standard exception, we're accounting purely for the 0 division error. And this allows us to do a lot of good things. Now, this is generally just good practice in general, really, because if you're expecting an error and you get a different error, if you just do except, it will account for every error and you won't know that the other error was there. So this will only throw up if there was a 0 division error. So for example, if I set this as an attribute error, it's not an attribute error, meaning that we get a 0 division error and the program crashes like normal. What we can do on top of this is, if I can get rid of this because it's annoying me, is we can actually handle for more than one error type. So we can do except name error as E, print there was a name error. And we can just up here do you try to divide by 0. And then that'll do. What we can do here is so we do x plus equals 1 up the top. You can see there was a name error because in this instance a name error would be thrown, and so we're catching it here in name error and then printing there was a name error. Now obviously you would probably not just print errors in most instances. You would do something like this if you wanted to ignore errors but you still wanted to log them, or you could do a certain situation where you print a message, maybe save the database or something like that, do kind of some extra cleanup in case there was an error, or try and reset a while loop, for example. So you could, if you're in a while loop, you could have a continue, like actually I might do that example just real quick after I finish talking about everything. So there are some other things we can do. So there is an else clause. We're just going to pass it for now, and a finally clause. Now this pass, I haven't talked about this pass yet. This is basically just a placeholder, pretty much. So you can do try except pass to just ignore errors. So if I do like try something and then you do except pass, this will do something, and if there was an error it will just ignore it. It's basically an easy way of doing it, but I'm just using it here to kind of demonstrate it. So the else in itself gets triggered if there wasn't any exceptions. So we can print there wasn't an exception. If you do, okay, that was interesting. I completely forgot you can do that in Sublime. So you can see x equals 1 divided by 1. That's perfectly fine. So we didn't hit a zero division error. We didn't hit a name error. So it goes down here. It says there wasn't an exception. This finally is very much like the else, except it's called every time. So this is the final step. As you can see here, so this is valid code, so it doesn't error, meaning we hit the else, and we print there wasn't an exception, and then we do the finally step. This is the final step. However, if there was an exception, and as you can see, we try to divide by 0, division by 0, and then this is the final step. It executed this finally anyway. Now I believe, let's get rid of this. And let's try and do plus equals 1, because I believe even if it raises like a proper error traceback, it still does the finally. Yeah, it does. It does the finally, and then as you can see, it raises the error and crashes the program. So if you wanted a system where you had a general crash handler, for example, and you wanted to have some logic that's saved to a database or committed to a database, basically make sure that everything was saved and cleaned up before the program crashed, then you would do that in the finally in here. So it would save if everything ended okay, it would save if everything crashed, etc., etc. So the error handling system in Python is actually fairly powerful. I quite like the syntax of it as well. I think it makes a lot of sense. So there isn't really much else to actually talk about except raising custom errors. I believe, did we talk about that in understanding errors? I really don't know. I think we briefly touched on it. Before I end this video, I did say earlier that I would do the while continue example with this, so I'm going to do that. So if we just kind of comment that out, that's the wrong button. I'm so used to my custom mappings of VS Code. So we have while true, number equals int, input, enter a number. Now you'll remember this from checkpoint 2, the number guessing game. We're not going to bother doing the guessing thing. We're just going to do the extra error handling segment. So we can, well, actually be, this would be in the try section. And this would be, I think, a value error. I can never seem to get the proper error the first time. So this might be a type error. I don't know, but I think it's a value error. So if it's a value error, we can print error, and then we could do E. Please enter. Actually, we'll just have this anyway. Please enter a valid number. And if we do else, we then print number. Or we could do the number is number, and then we can do a break, and then here we would do we don't even need to do a continue actually, because we're doing our standard stuff in the else, and then we could do finally. Thanks for, actually no, because that's going to run every time, that's going to be annoying. So if we run this, actually I just realized I've got to run it in the terminal, because the Sublime thing doesn't like, I'm not really sure why it doesn't like inputs, but it doesn't, which is kind of interesting. I'm going to make this a little bit bigger. So we programs Carberra plans how to Python. I think that's the correct directory. Yeah, it is. So pi try except.py. Enter a number 5. Okay, number is 5, so that worked fine. Enter a number hello. Here we go. It was a value error. So invalid literal for int with base 10. Hello. Please enter a valid number. We can keep doing this all we want, and then when we enter a valid number, it will print our number is 45. So that is how you can get some proper error handling in there. So if you want to go back to your checkpoint 2 task and implement this error handling, then you can do. But yeah, that's all there really is to talk about with try excepts. They are very easy to understand, and they're actually really very useful, as is any sort of error handling in any language, really. So it's a really good thing to have. If you have any questions about anything you saw in this video, then feel free to leave a comment below, or you can join Discord using the link in the description. While you're down there, I'd recommend that you check out my socials, because I have them all down there, so feel free to go nuts. But yeah, that's going to do it for this video. If you liked it, then say hello down below. If you really liked it, consider subscribing and hitting the notification bell so you don't miss out on future uploads. If you really, really liked it, consider supporting on Patreon. Of course, you don't have to, but really cool thing of it to do. With that in mind, I'd like to thank my awesome patrons for being awesome. And I'll see you next time where we talk about indexes and slices. So we're going to be talking about slicing lists and stuff. And that's going to be a lot of fun. So I'll see you for that.